The NES does not store colors, it synthesizes them. Colors are created by a kind of mixture of timed voltages. This tricks old TV's analog circuitry into producing a specific color with a particular hue and brightness. Modern systems have RGB color registers. The NES PPU does not calculate RGB. I'll explain what RGB color registers are. In many modern video hardware systems, and even some later 16-bit systems like the SNES and Genesis, the color of each pixel is a combination of red, green, and blue values, RGB. These are called digital intensity registers. They are typically 8 bits per channel. The RGB values are converted into analog voltages and sent to display. However, the NES outputs a single, fluctuating voltage line, one composite video signal. The PPU, or Picture Processing Unit, did not know what red or green really meant. The NES's PPU never stored any digital RGB values. 54 of these 64 possible composite voltage patterns were visible or even stable on a real NTSC screen. There were 6 bits per color entry, and each 6-bit value would correspond to one of these voltage patterns. The NES PPU would interpret the 6-bit color entry as a voltage pattern, where bits 0 and 1 correspond to the brightness or luminous, which actually scale from 0 to 3, and bits 2 through 5 deal with hue or phase, ranging from 0 to 11 in value. These are voltage pulses on a single composite video line that can be likened to a musical rhythm, where the TV hears the voltage pattern and interprets it as color. The way this works in NTSC TVs is that at the start of each scan line, the incoming waveform's phase is compared to a reference color burst. Brightness and hue are both determined by amplitude of the waveform and phase shift, respectively. So simply put, the NES PPU did not use RGB value to generate color. Rather, a 6-bit color entry tells the PPU how to pulse voltages into color. This is why NES games can look different on different TVs or emulators. RGB color depends on the TV's analog circuitry. The NES PPU does not fetch for RGB triples. Rather, it emits an electrical waveform with a timing pattern, which corresponds to a phase of the NTSC color subcarrier.